Assalamualaikum and good day everyone. We are from the BMKT3453 Computer Simulation course. Today, we will present our project 1 which is the finite element analysis or FEA of a bicycle frame. This project was supervised by Dr. Muhammad Shukri bin Zakaria. Our group consists of Auni Nasuha, Nurul Nazia and me, Siti Aisyah. I'll be presenting a study on mountain bike frames, specifically comparing two materials, which is aluminium 6061T6 and magnesium AZ91D. Mountain bikes are getting more popular because they are good for the environment, health, and they are cost-friendly. The frame is the most important part of a bike because it handles all the force from pedaling, braking, and riding over rough terrain. While materials like steel and aluminium are strong, they can be heavy. Magnesium alloys are lighter, which could improve performance. To test which material is better, we use finite element analysis (FEA) with software like SolidWorks and ANSYS. These tools help simulate real-life forces on the bike frame so we can see how each material reacts without building a physical bike. To begin the analysis, we first referred to research articles to obtain standard bicycle frame dimensions. These specifications were important to ensure our model reflects a realistic and functional bike frame. As shown in the table, the geometry includes angles and length for various parts of the frame such as the seat tube, head tube, and top tube. These values were then used to construct our 3D model. This slide shows the development process of our 3D model. In Figure 1, we began with a 2D sketch of the frame using the measurement from earlier. Figure 2 shows the fully constructed model, which we created using CAD software. Finally, Figure 3 displays the meshing process, where we apply at 5mm element size to prepare the frame for finite element analysis. This meshing is essential for accurate simulation and stress distribution analysis.
Hi, my name is Auni Naswa binti Muhammad Ghazali. I will present about method to construct 3D model. After we collect all the important specification and measurement, we start to design the bike frame using SolidWorks 2022. We use tools like Wheelmill, 3D Sketch, and Trim or Extend to help us drawing the model. These features are important to create a proper 3D model of the bicycle frame. This picture here shows our final 3D design. For reference, to make sure our simulation is correct, we refer to a previous study that used finite element analysis. We follow their example by using a basic bicycle frame design, just like the one shown in an image. This helps us to compare our result and check if our analysis is valid. Next, we apply the load and boundary condition based on the information from the journal. This means we test the frame under different force such as steady state up, steady state pedaling, vertical impact, and rear wheel braking. We propose it to observe how a big frame reacts, especially how much it deforms and how much stress is received, which we measure using equivalent von Mises stress. Next, for the material properties, in this part, we use aluminium 6061T6 as our material. This material is commonly used in a bicycle frame because it is lightweight but still strong. The journal also used this material in their simulation, so we follow the same to get reliable result. To get accurate result, we did not just select the material, we create our own custom material in ANSYS. We use the mechanical properties from the journal like density, Young modulus, Poisson ratio, yield strength, and ultimate strength. This ensures the simulation behave the same way as in real-life conditions.
My name is Surana Zihab. I will continue the presentation about the result from our project. For results, we took the maximum stress data readings in the total deformation sections to compare our result with the readings from the article. We took the total deformation readings on the static startup, which is 0.0193 mm, while the maximum stress from the article is 0.0197 mm. Then, we calculate the validation error percentage readings, which we got the value is 2.03%. Table 4 shows that mesh refinement from 5.0 mm to 4.0 mm, which coarse mesh 5.0 mm, medium mesh 4.5 mm, and fine mesh 4.0 mm results in only minimal stress changes 0.0193 to 0.0195 with a small error of 0.52%, indicating result convergence and confirming that the 4.5 mm medium mesh offer an optimal balance between accuracy and efficiency. For this part, we put the load on three different parts, namely steady state pedaling, vertical impact, and rear wheel braking. After that, we recorded the maximum stress reading on all three parts and compared them with the article data readings. We also calculate the value of validation error. The highest equivalent stress value was used to calculate the factor of safety based on tensile yield strength of 276 megapascals from ANSYS. The resulting factor of safety was 12.63 megapascal, much higher than the required maximum of 3.0. To meet this requirement, the target maximum stress was set by dividing the yield strength by 3.0. The force versus maximum stress graph shows a clear linear relationship, indicating that as force increased, the resulting stress on the material also increased proportionally. This is based on the assumption that the material's cross-sectional area remain constant. Data points on the graph show how stress rises with force from about 23.07 megapascal at 2,186 Newton to 93.23 megapascal at 16,850 Newton. This linear trend helps identify key mechanical properties like the yield point and elastic modulus, making the graph useful for evaluating material strength and selecting suitable materials for engineering and construction purposes.
Based on the simulations, aluminium 6061T6 performed the best. It handled the loads well during pedaling, braking, and impact. The maximum stress recorded was 21.86 megapascal, which is much lower than its yield strength. That means it's safe and not easily damaged. It also showed lower deformation, meaning it holds its shape better. Plus, the results were consistent and matched with data from other research. Overall, aluminium 6061T6 is a strong, reliable, and affordable choice for mountain bike frames. It gives a good balance between strength, weight, and cost, making it a smart material for manufacturers and riders. Thank you.